Hello and welcome to yet another thrilling installment of the Algebra 2 videos. This is section 5 and this is transformations of quadratic functions. Okay, and what we're going to do is we're going to use complete the square to write a quadratic function in the form of y equals a times the quantity x minus h squared plus k. We want to describe the effects of the changes in a, h, and k to the graph of the function in the form of what we just had. Okay, and that should be squared, not just times 2, okay? So, what we have to think about, our parent function, okay? And so when we have this function, f of x is equal to x squared, okay? F of x equals x squared. This is our parent function, okay? And what this means is that this function is kind of the easiest function, okay? It's the easiest, all right? And we call it the parent function because it's the most simplest of the quadratics that we have, okay? So the one thing you want to recognize is that the points are always here. The point 0, 0, the point 1, 1, the point 2, 4, okay, are all on this graph. And the same thing over here. It's reflected across the y-axis. You've got the point negative 1, 1. You've got the point negative 2, 4, okay? So when we do something, when we talk about transformations, we're really talking about, either a translation, which is a slide, okay? We're talking about a reflection, which is like a mirror, okay? And then a dilation is where you stretch or shrink the parabola, okay? So what I have here and what I want to show you guys is that the graph here that you see in orange is your parent function, okay? Okay, this is your parent function. All right, and this is just going to be the function y equals x squared, okay? Now, if you have this purple function down here, okay, that function has been reflected over the x-axis. So this is a reflection of the parent function. Okay, this is a reflection, okay? The blue function, that function is a dilation. Now what I see is that it's in the same position, it's pointing upwards, and what that's done is it's gotten just a little bit steeper. So this is a dilation, okay? And then the green function, all right, that function here is a translation, okay? And that's just been, and what you can see about that graph is that graph has just been shifted over 2 or 4 units to the left, okay? And every point is just shifted over. So, these are all terms that we learned back in geometry, and what we're going to do is, we're going to see how that applies and how that affects the equation of a graph, okay? So if I have a vertical translation, okay, a vertical translation means that the parabola is moved up or down. Okay, so vertical translation, let's write that that's when the graph is moved. So the graph is moved up or down. All right. And this one's really easy to spot. These are my favorite. And so what I know is that if I have this function here, say y equals ax squared plus k, where a is equal to 1. So I'm going to rewrite this equation as y equals x squared plus k, okay? When I have the plus k, okay, that's added to the y values, and if k is positive, okay, and that's what that means here, so k is positive, then the graph goes up, okay? So if k is positive, that means you go up. And then it says here that if k is negative, k is less than 0. And so I'm going to write that if k is negative, then that means that the graph is going to go down, okay? And so let's just think about something here. We have our parent function here in blue, y equals x squared. But let's say I have the function, say y equals, say, x squared plus 1. Okay, let's say I have the equation y equals x squared minus 1. Okay, this means that we're going to shift the graph. So this plus 1 here means that we're going to shift up 2, or shift up 1. All right, and then the negative 1 down here means that we're going to shift down 1. Okay, and so that's what we're going to have. So if I were to take this point here, just a graph, and let's just identify the points here, 0, 0, 1, 1, 2, 4, 3, 9, okay, negative 1, 1, what do we got? Negative 2, 4, negative 3, 9. Okay, if we were going to do the shift up, okay, this part right here, then that means all these points are going to be moved up 1, okay? And that's what's happening here. They're all shifted up 1 unit, okay? And so if I draw a graph there, I have the same parabola, roughly speaking, even though my drawing might not be very good. Okay, this has been shifted up 1 unit. Okay, now if we do the same thing here and we shift down, we go down 1 unit from each of these points, and that's all we're doing is just moving these points up or down, then that's the same thing we have here, okay? So we're just shifted down 1 unit. Okay, and that's kind of an easy thing to do, but that's kind of the idea. If we wanted to do, say, like, let's say we had something in green here, and let's just make something up and say y equals, x squared plus, say, 4. Okay, this means that we're going to shift the graph up 4. So shift up 4 units. So what I'm going to do here is from this point here, I'm going to go up 1, 2, 3, 4, plot a point. From here, I'm going to go up 1, 2, 3, 4, plot a point. From here, go up 1, 2, 3, 4, and plot a point. And we have that parabola there, okay, as well. So I know my drawing isn't perfect, but, deal with it. That's all I got. Okay, next page. Okay, on this one, we're looking at horizontal translations of y equals x squared. And horizontal translation, then that means that we're going to move it either left or right. Okay, left or right. Now, the issue with a horizontal translation is that it's backwards. So that's backwards from vertical. So backwards from vertical. Okay, and you may have seen something like this, but we're just going to go ahead and talk about it. So we're talking about a horizontal translation of y equals x squared. That's our parent function. Okay, y equals a times the quantity x minus h, that whole quantity squared when a is equal to 1. Let's rewrite that. If a is equal to 1 is y equals just x minus h quantity squared. And so what we have here, and it's kind of weird, but what we have is because h is subtracted from x, the same graph appears when x is h units greater. Okay, that doesn't really make any sense to me, but let's talk about these two options here. And what it says is that if h is positive, okay, the graph shifts 8 units to the right, okay, and if h is negative, the graph shifts h units to the left. So now let's do something here, okay? Let's say that h is positive. Let's say that h is equal to, let's say that h is equal to negative 3, okay? So, or let's just say that h is equal to 3, sorry. So h is equal to 3, all right? Now, if I were to plug that into this function up here, then it would be this. It would be y equals x minus h, okay, because it's minus h and h is equal to just positive 3. So x minus 3 quantity squared. Okay, this would move this. Now, because what you see here, what you end up seeing is that the value here is negative 3. Once you plug it into this function up here, this means that we move it 3 units to the right. 3 units right. Okay, and that's what that graph shows over here, this green graph here, x minus 3, okay? This is 3 units to the right. This is what I mean by the opposite. So this is 3 units right. Okay, 3 units right. And then, okay, if it's, when you have the orange one, let's just say that h is equal to negative 2. All right, so if I come over here and I say, all right, well, let's let h equal negative 2. If I plug that into my function up here, all right, then look what happens. I get, or I'm sorry, negative 2 should look like that, not a negative 3. So negative 2, if I plug that in, I get y is equal to x minus negative 2 quantity squared. So this then becomes y equals x plus 2 quantity squared. Okay, and what happens is that you get this where you have the negative, or this 2, okay, positive 2. This means that you're going to go 2 units left. Okay, This is what I mean by the opposite, okay? So when you had the other one, when you had the vertical, okay, remember how that just followed the sign, all right? But it's kind of hard to determine what the value of h is. It's kind of backwards because you have a minus h in the formula. So what you have to do is you have to just kind of look at it and say, all right, if I have, if inside the parentheses, in the horizontal translation, let's put this, okay, there's a disclaimer here, okay? A disclaimer is that the horizontal translation is inside the parentheses. So inside the parentheses. Okay, and that's how you can tell whether you're going to shift left or right. Okay, is for left or right. All right, left or right. If we move up and down, it's outside the parentheses, and so if we move up or down, okay, it's outside the parentheses. Okay, that's what helps me. All right, so if you're trying to figure, if you're sitting there going like, well, wait a minute, parentheses, this parenthesis. If you're trying to figure out, which one goes where and how do I know which one is what, okay, I know that if it's inside the parentheses, we're going to move it left or right, outside the parentheses, up or down. This is the opposite, okay, opposite of the sign. Okay, and this is the same as the sign. So same as the sign. All right, and so that's all we're looking at. Okay, and so that's where those values come in. So this leads us into this thing called vertex form. Okay, when you see an equation of this form, y equals a times the quantity x minus h quantity squared plus k, this is in vertex form. Okay, where a can't be 0, okay, they're all real numbers, and h of k is the vertex of the parabola. That's either going to be your minimum or your maximum, okay? And so what you have here is you have this, this graph here, okay, of y equals x minus 2 quantity squared plus 1. So what this means, when I look at this, okay, when I look at the x minus 2, because it's negative, that means that's going to be a shift shift right 2 units. Okay, and then the plus 1 is a shift up 1 unit. Okay, and so if I look at 0, 0, okay, and let's remember 2 units to the right, 1 unit up. Okay, if we think of our parent function of these points here, 2, 4, 3, 9, all right, and the same points over here, all right, then what I can see here is that each of these points is moved 2 units to the right and 1 unit up, okay? And you know that the vertex of the parent function here is at the point 0, 0. Okay, that's the vertex. Okay, this is also my new vertex. Okay, and same thing with the points here. From this point, 2 units to the right, 1 unit up. 2 units to the right, 1 unit up. All right, same thing over here. If I did 2 units to the right, 1 unit up, it gives me all those points. Okay, and so that's the idea, is that you want to just be able to look at a graph or look at an equation here, and then say, all right, well, this is the, I have a vertex at the point 2, 1. So when I look at this equation again, you think of the vertex, okay, of that equation, okay, remember, it's of the form hk, all right? So if I look at this thing here, it's x minus h plus k, all right? And so h is just the value that you have there. H is a value of 2, comma 1, and that's it. And that was my vertex that we had over here on this graph, okay? So all we're doing is just shifting and moving them around, guys. Okay, so then it says choosing the graph of the given values for h and k. So if I have this, okay, x minus 3 plus 1, that means it's going to be a shift to the right 3, so I'm going to go right 3. All right, and the reason why I know that is because this is a minus 3. So it's opposite of what it is. Okay, if you go right, typically it's positive, but because of the way the formula is set up, we're going to go to the right 3 when it's negative. So it's right 3 and then up 1. Okay, so if you think about that, then you just have to think about that you have the point, your vertex, okay, is going to be the point 3, comma 1. All right, and then you come over here and you're like, okay, which one has a vertex of 3, comma 1? And it's that one right here. Okay, so not too bad, not too terrible. We're getting it. All right. But now let's talk about this whole A thing. Okay. If we talk about A, all right, if we look over here, all right, we talked about just a simple, if the blue function is my parent function, adding a K just moves that graph just up. Okay. If we subtract an H, that means that we're going to move it over, okay? And then if we combine them both, it's going to be up and over in some fashion, okay? So let's talk about how you make the values, just a little bit skinnier, okay? And so if you think about, the two graphs that we had here, how A affects the orientation of a parabola, if A is positive, so if A is positive, A is greater than 0, then the graph opens up. Opens up. All right? And what that means is that, when you have this parabola here, that the graph just opens up, kind of makes a U. Okay, if your leading coefficient, if your A is less than 0, okay, if A is less than 0, then you're going to open down. All right? All right, and we kind of just dealt with the same problem over here. I don't know why that's sitting there again. But let's say, okay, so let's select the graphs that have an equation where A is less than 0. So this is, if A is less than 0, that means it's going to open down. All right? And so this graph here opens up. Okay, this one opens down, so this one works. If we look at the next one, this graph also opens down, so this one also works. And then if we open up, then that one opens up, so that one doesn't work. So you can tell which one is which. Okay. Now there is a little bit of a disclaimer here. What I know is that if and this is where it gets kind of funky. If the effect that A has on this graph, so and they have all these different things. If A is greater than 1, the parabola stretches vertically. If A is less than -1, the parabola flips over the side and then stretches vertically. And then if you have that A is a fraction, then it shrinks and it vertically and it widens, okay? So when it says that it stretches vertically, if A is greater than 1, then that means that it's going to get thin, okay? And then if A is less than -1, okay, it means it's also going to get thin. And then if the parabola shrinks, it widens, that means that it gets fat. Okay, and these are for values of A that are fractions, okay? So here's what we know, okay? Here's what I want to show you. And A is sometimes called the stretch factor of a parabola. But if we come in here and we look at it and we say, okay, the graph here in orange is my parent function, okay? It's just your standard f of x is equal to x squared graph, okay? If my value in front, if the coefficient is 2, and this number is larger than 1, okay, so 2 is greater than 1, that means that it gets thin, okay? And you can see that graph here in purple, how it gets thin, okay? If you have a number that is smaller than 1, okay, but greater than 0, so 0.5 is less than 1. So let me do this, that 0.5 is less than 1, that means that you're going to get fat, okay? And so that's where this green graph is here. It gets wider, gets fatter, okay? Same thing over here. Now, if they're negative, that means that they're going to open down. They're going to be reflected across the x-axis. But notice that 1/6 here, okay, 1/6 is still is a fraction. So both of these are fractions, and they make you fat, okay? So, and then you have just, f of x, or this is I of x. This function here is just negative x squared. which is that function here, and then you have negative 4. So negative 4, we know that negative 4 is less than negative 1. Okay, it's a large number. It's going to be pointed down, but because the value is 4, it's going to get thin. Okay, so I have a saying here, okay, and it's something to help me remember how to do these, because I would always get confused on what would happen. So the way I think about it is I kind of think about it as a person, and whether a person is fat or thin. Okay, so if someone is fat, if someone is fat, if the graph is fat, okay, fat or thin, okay, the graph is fat, then they don't need to eat much. So if the graph is fat, then we need to eat less, okay, which means that you have a fraction as your coefficient, okay? But if you're thin, you need to eat more, okay? And that your coefficient is a number is bigger than 1. So coefficient is bigger than 1. Okay? And so that's kind of how I think about it. Okay? If the graph is thin, okay, you need to, or I'm sorry, if the graph is fat, this graph, the green one, you need to eat less. Okay? 0.5 is less than 1. If your graph is thin, like this blue one, okay, then you need to eat more. All right? Meaning that this number is bigger. Okay, same thing down here. Okay, this graph was really fat, and that's because, you had to eat less. 1/6 is kind of a small number. Okay, if your graph is thin, you needed to eat more, which is 4. Now, just remember that the negative sign just flips the parabola over the x-axis, and you're fine. So kind of a weird way to think about it, but hey, you know what? Whatever gets you guys to learn it, I don't care, as long as we get it right. Okay, now it's kind of hard to identify what this number should be. Okay, now if I just think about my parent function, okay, let's just, they give us this function here, y equals 5 times x minus 7 quantity squared plus 9. If I were just to think of another one, which would be the graph of, like the parent function, y equals x squared. I know that on that graph I have the point 0, 0, and I have the point 1, 1. Okay, and I have the point 2, 4. All right. Now, what happens is that if I were to say, well, let's think about y equals 5x squared. Okay, because this number 5 is big, it's going to get thin. Okay, remember that I need to eat more. Okay, if 5 is more than 1, then I'm thin. I need to eat more, so I'm thin. Okay, and what happens is that when you have that, you'd have this point here, and you would have the point 1,5. Okay? So it's the distance that's between this point here and that point there. Okay? If you go over 1, you should go up 5 instead of just going up 1. All right? It's a little harder to see on this graph, but what you see is you have the point 7, 9. Okay, that's our vertex, and that comes from these numbers here, 7, 9. And then when you think about it, all right, here's 7. What about the value of 8? And that value, okay, when you think about 8, you have the y value of 14. Okay, and so this point here is the point 8, 14. And so the difference between 14 and 9, 14 minus 9, is going to be 5. And that's what gives us this value here. You kind of have to think about that first point that does that, okay? All right, let's take a look down here. Let's, I'm going to go ahead and, we always know that the parabola given in this form is going to have the vertex of just hk, okay? But if I have the coordinates here, we want to know the coordinates of the vertex given this, what I know is that my value of h, because this is positive, is going to be shifted over to the left. This is a shift left. So you shift left 5 units. Okay, so the point would be -5, comma, and then this down here, this -4, this is down 4. down 4. So then minus 4 here, and that would be my vertex, okay? All right, so now let's look at completing the square to change a quadratic function to vertex form. And so what I want to do is just kind of start that process and walk you guys through it. Now what I want to do is identify the a value, so a is equal to 1, b is equal to -4, and then c is equal to +5, okay? Now what I want to do is complete the square here. So I want to remember that I need to take my middle term b, my b term, divide it by 2, and then square it. So I'm going to take -4, okay, I'm going to divide it by 2, and then I'm going to square it. Okay, and that's going to give me a value of, what is this, -2 quantity squared, so it's going to give me a value of 4, okay? Now what I'm going to do with this number, okay, this is my first step, I'm going to rewrite this. I'm going to say y is equal to x squared minus 4x, and I'm going to add the 4 here, okay, just like I would to complete the square. But then I have this plus 5. But the problem is that if I add 4 to this, then I don't have the same equation as I did up here. But if I do this, if I subtract a 4 as well, then what I can do is this stays balanced because 4 minus 4 gives me 0, which gives me back where I started. Now what I can do is this, is I can take this for my first 3 terms, which is my trinomial, and identify that this is a perfect square, and I can factor this. And I would then get y is equal to x minus 2 times x minus 2, and then over here I would have plus 5 minus 4. So 5 minus 4, that would just give me a plus 1. Okay, now this, because I had, the two numbers -2 and -2 add to -4 multiply to +4, since I have two of the same, all right, I get y is equal to just x minus 2 quantity squared and then plus 1. And that's it, okay? And notice how this number minus 2 here is the same number that we got by dividing our middle term by 2, okay? The trick, though, is this, when you add that number here to your trinomial, then you have to then also subtract it over here, okay? So then my vertex, all right, what's our vertex? Okay, our vertex is going to be the point, and because it's -2, we have to think opposite, okay? So it's going to be a shift. This is a shift right 2 units, so I'm going to have the point 2, 1, okay? And that's it, all right? So, if I were to just sit here and kind of just sketch a graph, okay, 2 over 2 up 1, and then just draw my parabola, and that's it, okay? Now let's just go ahead and plug this into Desmos and see if we did get this right, which I hope I did. Okay, sure enough, that's what I've got is the point 2, 1, okay, which is what I thought it was, and so we are correct. And this is, I just graphed the original function over here, but you can easily just tell with the transformation that that's the value of the graph there too, okay? Okay, so let's take a look at doing the exact same thing when the value of A is not 1, when your leading coefficient is not 1, so you have a 4 here. Okay, so let's take a look at what we should do there. So the first thing that I want to do is take a look at my first 2 terms here. What I notice is that I can look at these first 2 terms and I can factor out a 4 from each of those terms. So let's go ahead and do that real quick. So if I wrote this as y equals 4 times the quantity x squared minus 2x quantity and then plus 5, okay? So then what I have is I want to be able to do the perfect square here, okay? Just look at this, all right? But I have to account for this 4 later on. So watch what I do. Okay, what I want to do here is complete the square to this, what's inside my parentheses. And so I'm going to take -2, I'm going to divide it by 2, and then I'm going to square it, okay? And that's just going to give me -1 quantity squared, all right? So then what happens is this, okay, which this is just going to give me 1. So I'm going to do this. I'm going to do y equals 4 times x squared minus 2x and then plus 1, okay? And then I have this plus 5, but because on the last one I had to keep it balanced, the thing of it is I have to subtract something. So I added, let me do this, added 1. Over here, I need to subtract, you would think would be a 1, but it actually has to be a 4 because I have this multiplier out here by 4, all right? Because if I were to multiply this whole thing out, okay, by 4, I would get 4 times 1, which would give me 4 as a number here. I'd have to then subtract 4 as a result, okay? Now what I can do is this, okay? I got y equals 4. This can now be factored into x minus 1 times x minus 1. So x minus 1 times x minus 1. And then plus 1 out here. All right, so then you get y equals 4 times x minus 1 quantity squared and then plus 1. All right, so now that's my graph. All right, and so what I know is that my vertex of this graph, my vertex is the point 1, 1, all right, because I have a minus 1 here. That's going to be a shift right, so I'm going to have the point 1. And then we have a scale factor of 4, okay? And so my graph is going to look more or less something like this. Okay, here's my graph. Here's the point 1, 1, okay? And then it's going to be really a thin parabola, all right? And I'm just sketching it. All right, let's go ahead and just type in our original value here into our calculator and see if we get the same thing. Okay, and sure enough, that's what we've got. Having the vertex of 1, 1, okay, and then having it be pretty steep and having it be a thin parabola, okay? All right, let's go ahead and let's do just one more. I'm going to complete the square on this one here and do the exact same thing. So let's do that again because that was kind of tricky. I'm going to write this equation down here as y equals 3x squared plus 12x plus 7. Okay, and what I'm going to do is I'm going to factor out, I'm going to look at these two terms, I'm going to factor out a 3 from each of those. So I've got y is equal to, if I factor out a 3, I'm left with x squared plus 4x, leave that quantity, and then add the 7, okay? And then what I'm going to do is I'm going to complete the square on my new value here, x squared plus 4x. So I'm going to take the value of 4, divide it by 2, and then square it. Okay, and 4 divided by 2 is going to give me 2, and then square it, so it's going to give me 4. So watch what I get. I'm going to get y is equal to 3 times x squared plus 4x, and then plus 4, okay? And then I'm going to have the plus 7 on the outside. And then what I want to do is I want to think about, okay, how would I keep this balanced? But you have this factor of 3 out here. So what you have to do is then take subtract 3 times 4, okay? And so let's kind of clean this up a little bit. This is going to give me y is equal to 3 times x plus 2 times x plus 2 after I factor that. And then plus 7 and then minus 12. All right, so you get y is equal to 3 times, this becomes x plus 2 quantity squared, and then minus 5. And that's the value that we're looking for. So you do need to be able to do this algebra, guys. It's pretty important. So hope you enjoyed this video. I know it's a long video, but it's a lot of information, a lot of good stuff in there. So talk to you later. Bye.